Today is the last day we are solving systems algebraically. And what I mean by that is substitution and elimination. After today, we're still going to be solving, but we will be graphing. Okay. What we are covering today is solving nonlinear systems. What I mean by that is at least one of the equation is not linear. So I want to review real quick if you can write this down. Linear is going to be something like x plus 2y equals 7. Has a plain x and a plain y. If something is nonlinear, it might have an x squared or a y squared. It might have x times y is equal to some number. It could have a log. It could have an exponential. Now, at the end of the day, it doesn't matter. You're still just going to use substitution and elimination. If we look at this first question, solve the system. Which equation is nonlinear? The first one or the second one? Second one. It has an x squared. So what you have to decide is, am I going to use substitution or elimination? In this case, using elimination, probably not a great idea. Substitution is probably our better option. If we look at the first equation, which is a little bit simpler, which variable is easiest to solve for? Y. Okay, so let's do that. First equation, we solve for y, and we get 3 minus 5x. Second equation, y is already solved for. This type of system, when it looks like this, is when students often get confused. If you have two equations that are y equals, set them equal to each other. Set them equal to each other. So when we do that, we get 3 minus 5x is equal to x squared minus 3x minus 5. Before we solve this, can anybody tell me how many solutions there will be? Two. How do we know? X squared. Where do I need to go then? How would I approach solving this? Okay, simplify, move everything to one side so that we're set equal to 0. So I'm going to subtract 3. I'm going to add 5x. So everything is set equal to 0. I have x squared, add 2x, subtract 8. What options do I have for solving something like this? What's it called? Factoring, that's one. If it doesn't factor, what are we going to do? Quadratic formula. Okay, Charlotte, you already kind of gave us the answers. If we're factoring this, we're looking for two numbers that do what?
Add to 2
Okay, beautiful. And Charlotte, what are those two numbers? 4 and negative 2. So we get x add 4, x subtract 2. So that gives us then x is negative 4 and x is positive 2. So a little bit different than the other ones we've been doing. We're going to have two answers this time. And remember, our answer should be a point. So one point is going to be negative 4 comma something. The other point is going to be 2 comma something. So off to the side, I'm going to write our answers. One of them is negative 4 comma some y value. The other one is 2 comma some y value. So the question is, how do I find the y value that goes with those two x's? Plug it in. Yeah, we have two options, these two equations in green. Which one do you think is easier? First one. Yeah, use the first one. Do less work. Okay, so if I plug in x equals negative 4, I'm going to get y equals 3 subtract 5 times negative 4, which is 3 add 20. So that y value is 23. So our first point is negative 4 comma 23. Then if we substitute in x equals 2, we get y is equal to 3 subtract 5 times 2, which is 3 subtract 10, which is negative 7. So those are our 2 points of intersection. Not too bad. It is still possible to get no solution. No solution would be you end up with a false statement, 0 equals 5, something like that. Technically, you can get infinitely many solutions as well, it's just not very common. Okay, real quick, I want to talk about why there's two answers here. Remember, this all relates to graphing. If we were to graph this first equation, what would the shape be? Line. Plane x, plane y. First equation is going to be a line. What about that second equation? Parabola, x squared. What else do we know about the parabola?
2 points that intersect.
Eddie? Opens up. It does have 2 points of intersection. It opens up. So this is what we're looking at. A parabola that opens up and a line. Of course, that's not a super accurate graph, but we have a point of intersection here, point of intersection here. So what I do think is hard about these is looking at the system, you don't know how many solutions there are going to be. So we got to be a little bit careful of that. That's the first type that you're going to see. Do we have any questions with that? Okay, try the next one. So here is our next one. This one a little bit tougher because we have x squared and y squared. Again, our two options are substitution or elimination. Is it going to be easy to solve for x or y in either equation? No. If we try to solve for x here, let's say, we would move the 2y squared and then end up with a square root. Not ideal. So instead, we're going to approach this using elimination. Let's say I want to multiply this bottom equation by -2. First of all, why would I do that? What's the benefit to multiplying the second equation by -2? Eliminating our x's. Okay, so first equation will stay the same. Second equation, if I multiply by -2, gives me -2x squared, subtract 4y squared is equal to -24. Okay, those x squareds drop out. So I get -y squared is equal to -3. What should I do now? Yeah, get rid of the negative. If there's a negative on both sides, get rid of it. So we get y squared equals +3. Take a square root. Here is the key. What do we remember with a square root? Plus or minus. Okay, so we have two values of y, which means we need the x values. Which equation would you all like to use, the first one or the second one, to find x? Yeah, I'm going to choose the second one because it's just a plain old 1x squared. But if you want to use the first one, you can. So that's what we're going to do next. We have y is equal to +√3. And then we're also going to do y is equal to -√3. So I get x squared plus 2 times √3 squared is equal to 12. √3 squared is just 3. So we're going to end up with a 6 here, which we can subtract, which gives us x squared equals 6. So our x is equal to plus or minus √6. Okay, so what I want us to notice here is this left side, or really the middle of our page, gives us two answers so far. So let's write down those solutions before we keep going. So far, we have x is √6 and y is √3. We have x is -√6 and y is √3. So y is +√3 and x is plus or minus √6. That's just from here. Then we have to do the -√3. So we get x squared plus 2 times -√3 squared. Okay, here's where we're likely to make a mistake. If I take -√3 and I square it, is my result positive or negative? positive. Negative number squared is going to be positive. So this becomes x squared plus 2 times positive 3. So again, we get x squared equals 6, and x is equal to plus or minus root 6. So we have x is positive and negative root 6, but y is negative root 3. So that gives us x is positive root 6 and y is negative root 3. Or x is negative root 6 and y is negative root 3. So all 4 of these are our solutions. If you want to write it a little bit more efficiently, you can also write plus or minus root 6, comma, plus or minus root 3. So this has the same meaning as those 4 written out. How do we feel? Okay? Questions for me before we look at 1 or 2 more? Okay, let's go on to the next page. I'm going to start us out, and then I'm going to have you take a minute or 2 to see how far you can go. First question for us. What do you think is our better option here, substitution or elimination? Elimination because we have the squareds. Together, we're going to decide what we're going to eliminate. You guys want to eliminate x or y? X. Okay, so right now, I want all of you to take 2 minutes, start by eliminating x, and see where that takes you. This is where I got to. I eliminated x. So I was left with 13y squared is equal to negative 64. Can anybody confirm? Yeah? Great. Then you should have ended up with y as an imaginary number. You can't graph that. It's not a solution, so we're done.
You wouldn't do an I?
No.
Okay.
No. Yeah, at that point you can just stop and say no solution. What does that mean about our 2 graphs? They don't intersect. Yeah. Yeah, don't do extra work. Okay. Are we okay if I take 1 more minute of our time to discuss something you're going to see in the homework?
Yes.
There's one last type of problem that's not on here, so I just want to give us an idea of how to start it. Okay, so if we can write this down, please. Let's say you have something like 3x plus y equals 10 and xy equals 5. You're going to have a few systems like this. So my question to us is, which is going to be a better option, substitution or elimination, and where do we start? Audrey? Substitution. You can't eliminate with this. Okay, Audrey, what do you want to solve for?
Y.
In which equation?
The first one.
Okay, first equation, if we solve for y, we would get 10 minus 3x. So in our second equation then for y, we're going to replace it with 10 minus 3x. This is where people generally make a mistake. Am I allowed then to say x equals 5 and 10 minus 3x equals 5? No. Only works if it's a 0. Yeah, so we would have to distribute, and we would get 10x minus 3x squared equals 5. I'm going to move everything to the right side, so that would give us 3x squared minus 10x plus 5. All I did was move this to the right side, move that to the right side. We're not going to keep going with this problem, but at this point you would factor or do the quadratic formula if you had to. Yeah, I just made the numbers up right now, so that's why. I don't think you should end up having to do quadratic formula though.